All right, this is going to be a demo of how to install the IPFS service provider, specifically setting it up as a circuit relay. I'm going to follow some instructions. So first of all, I'm shooting this video because some members of the Permissionless Software Foundation have wanted to run this software and they've gotten into issues, and so I'm going to show step by step on how to set it up and configure it as a circuit relay. So these step-by-step instructions are in a gist that I'm going to follow, and so you can just scan this QR code, which will take you here. I'll also put the link in the show notes if you're watching this on YouTube. But here is the gist. And so IPFS Service Provider is like this sort of generic boilerplate for building IPFS-based applications, specifically for this new paradigm of using the JSON RPC over IPFS, which is more censorship resistant than a REST API. And in particular, we need people to set up circuit relays. And a circuit relay is critical for circumventing censorship. The whole job of a circuit relay is to help nodes on the network that otherwise wouldn't be able to talk to one another. And so we've got some bounties set up for setting up circuit relays in geographically dispersed locations. So that's largely the focus of why we would set up a circuit relay. And so that's what I'm going to show today. So this demo is going to target the Ubuntu Linux operating system. That's the official target for all PSF software, and it's the most common operating system offered by VPS services like DigitalOcean, Vultr, Linode, Hetzner, others. And so that's what we're going to start at. Over here in this terminal, I have a brand new virtual private server, or VPS, on DigitalOcean. I've got root access. This is what you'd get if it was brand new. And so I don't like installing things as root. That's generally bad practice. So I'm going to show it the way that I normally do it, by creating a non-root user. And actually, I don't need to do that. That's with the add user command. Add user trout, and then just use a password. Password changed. Try again. There we go. And then I just hit enter to skip past all this stuff. And then I need to add my new user. I need to give them sudo permission, and so that I can make root calls. Okay, so now I'm going to log out and log back in as my new user. Permission denied. Dash P. Okay. Okay, I just discovered a little thing that makes DigitalOcean a little weirder. They disable passwords in SSH, which I kind of hate that. And normally I would just re-enable passwords. So instead, in order to use a non-root user and use the same SSH key that you use to log in as the root user, what I needed to do is copy the .ssh folder to the home trout folder for my user, and then I can go in there and change the owner to my trout user of the .ssh folder. So now the user has the same SSH key for logging in as the root user does. So I know this is one of those things where they're trying to be helpful, and it's really not. Let people worry about their own security. Don't be a nanny. Okay, so I'm logged in as my non-root user, and I'm going to, first thing you should do is update your system by running sudo apt update and sudo apt upgrade. So a lot of this is just going to be copying and pasting. And while I'm waiting for these kinds of updates, I'm just going to pause it so that you don't have to watch this with the video. Okay, so the Linux has been updated and upgraded. So next step is just to install and make sure your system has some basic tools. It may have some of these, probably won't have all of these. They're just useful things to have. Looks like it had most of them. Not every Linux installation has the same tools. Okay, so now let's install Node JS and Npm. Make sure it's removed. Oh, okay, that's installed already. Next we can install Node JS and build essentials. Okay, so Node is installed, but I want to upgrade NPM to the latest version. Okay, so I ran those commands, and now I have Node version 14 and NPM version 7. So just to quickly go over, this upgraded the system. These installed sort of environment packages that we needed. This removed Node.js if it existed. This set up the computer to install Node 14. This actually installed Node, and then this installed the latest version of NPM. And so now we have these versions of Node and NPM. So our development environment is essentially set up. We have a few extra things we need to do, but now we can clone the repository, this IPFS service provider repository. So we just cloned it, and then we're going to enter that directory and install the dependencies with npm install. Okay, the npm dependencies are installed. Now there's a couple other environmental dependencies that we need. We need to install MongoDB, and so all we got to do is just run this shell script, and that will install Mongo for us. Okay, Mongo is installed. And next, we need to install PM2. What PM2 stands for Process Manager 2, and that's what it is. It's a process manager. It will restart the app if it crashes, or in this case, at the time of this, there's currently a bug in the JavaScript implementation of IPFS, and it causes memory leaks. And so this app will automatically shut down every 8 hours to flush the memory. And so it relies on a service provider or a process manager like PM2 or Docker or systemd to restart the process. And that's currently how we're dealing with the memory leak bug. Okay, so PM2 is installed and Mongo is also installed. And so by default, all the nodes on the network are anonymous and generic. And so if you want to customize yours, which I recommend, there's this IPFS service provider shell script. And let's just take a look at that. So here you can define the different ports that you want it to run on. Because the whole purpose of this is to create a circuit relay, we're going to want to remove this hash mark and uncomment this line to enable circuit relay. And it's a good idea to give your node a custom name, particularly if you're going for one of the bounties. You definitely want to indicate like what geography it lives. And then this is optional, but you probably should replace this 12-word mnemonic with a new one. And so the way you do that is you go to open a private window, and go to wallet.fullstack.cache. And everything I just covered is actually right here, everything I just spoke to. So we're going to use nano, which is the command line app. I'll show you how to do that here in a minute. But once this comes up, just click this create wallet button, and it'll create a wallet, Bitcoin Cash wallet. That's not important. You can click this copy button on the line with mnemonic, and then you can close the window. And so we're going to use nano to edit this file. And I'm going to erase the old mnemonic. This is not used for money at all. This is used for end-to-end encryption, for any messages that other nodes send to your node. This way they can end-to-end encrypt it. So I just got a new 12-word mnemonic and put that in there. I'm going to rename this to demo circuit relay, and I'll give it some unique number. There we go. That works. And then because we want to run a circuit relay, we want to uncomment that line. Okay, so now I can hit Control X to exit, and I'm going to hit yes to save the modifications and enter to confirm the name. And if I do cat, I can see the file and I can see all of our changes are in place. Okay, so we're now ready to start the service provider. And so the directions say go ahead and start PM2, but actually I like to just kick the tires first, just by running the shell script first initially. And so what it's going to do is it's going to create a new IPFS node. And it's also going to error out if it can't connect to Mongo. It did connect to Mongo, so there was no error. And so it generated a new IPFS ID, and it's in the process of reaching out to the IPFS network. And it looks like everything's working fine, so I'm going to go ahead and hit Control C to close that down. Let's just clear all the history there. So I think we're pretty much ready to go. We can go PM2 start IPFS service provider, and that'll start it. And let's just check the PM2 logs. Looks like it's starting up okay. Okay, so the circuit relay's off and running. And so I want PM2 to automatically start this application if the machine reboots. So in order to do that, I'm going to run PM2 startup, and it's going to give me this command. And you can also run this command, but I just like to run the one that PM2 gives me. Okay, and now finally I can run PM2 save. So what that did is it basically set up the computer to automatically start PM2 at startup, and then PM2 will start up your different applications. And so when this shuts down, when the IPFS service provider shuts down, PM2 will automatically restart it, and if the machine gets like a hard reset, it'll automatically start it back up when it reboots. So let's just check our logs again. Yeah, it looks like it's up and running, and it's advertising itself. So that pretty much concludes the demo. So the circuit relay is set up, and so you can stop watching now if you want, but what I'm going to do is try to connect to the circuit relay and just make sure that it's running properly. And so I'm in the PSF BCH wallet repository, and I have other videos on how to set this up. But this is also on GitHub under the permissionless software group. Look for a repository called PSF BCH wallet, and this is what I'm going to use to sort of troubleshoot the circuit relay that we just set up, and just make sure that other nodes can see it and connect to it as a circuit relay. And it's a command line application, and so you can go bin run help to see all the different commands. And the very first command that you need to run is this daemon command. And what that does is it spins up an IPFS node and connects to the same network that the circuit relay that we just created is connected to. And it's going to reach out and try and find it. In fact, what was the name of the node? VSGN. So that's what we want to keep our eyes out for. VSGN. Okay, so it found it right away, which is good because this circuit relay is on the West Coast and I'm on the West Coast. I did it deliberately so that we could connect to it pretty easily. And okay, here it found it. Error trying to connect. Could not. What will happen is if it can't connect to it on the first try, it will retry over a period of time. Every couple minutes, I think, it tries to renew connections. Okay, new circuit relay added. Okay, so it found our circuit relay and it connected to it. So I think we just connected to it. So I have the daemon running in this window. I'm in the same directory in this window so that I can issue commands. And the way you can troubleshoot it is with these IPFS peers and IPFS relays command. So if I run the IPFS relays command, it'll show all the circuit relays that this node's connected to. Oh, and there it is right there. We're connected to it. True, it's not a bootstrap. So what it's going to do is it's going to, every couple minutes, I think, measure the latency between this computer and the circuit relay, and it'll track it. And so your node will the wallet, this BCH wallet, will automatically try and route traffic through the circuit relay that has the lowest latency. And so it's constantly, every few minutes, measuring the latency of the circuit relays that it's found on the network so that it can use the fastest one, which is usually a matter of geography. That's why we need these circuit relays. We want to have several of them dispersed around the world. And so I'm just going to give it a few minutes, and then we'll see how the latency lines up. Okay, so a few minutes have gone by, and let's see. Here's the VSGN, that's the one we just set up. And there's a number of latency tests. It will, if 10 seconds goes by, it'll basically count, that's the ceiling, it'll count the number as 10. So the connection's not great. I need to figure out why the connection's not great. There was one response that came back in 4 seconds. It's also found another circuit relay up here that it's having about the same connectivity, so at least it's consistent. And then there's these other bootstrap ones that don't get a score because they're sort of hard coded in. And but yeah, you can basically see when you get back this command, it will sort the relays by the latency score. Yeah, this one's less than this one. So it'll always try and use this circuit relay first. If that fails, it'll move on to this one, and so on and so forth. But it'll always prefer to try and find the circuit relay with the best connection and use that one first, and then use the substitutes as needed. All right, so that's how you set up a circuit relay. That's how you test that you're connected to the circuit relay and that it's functioning.